Hello students. So students, we will continue with the same chapter, that is friction. So in the previous class we discussed about the cause of friction, and today we will discuss about the factors affecting friction. Please open page 215. Okay, now see here, factors affecting friction here. Now you can see there are two factors which affect friction. First is the nature of the two surfaces, okay, and the force with which the two surfaces are pressed together. Definitely the nature of the two surfaces means that if the surface is more rough, the friction will be more, because there will be more, the interlocking between the irregularities will be more, so friction will be more. And the force with which the two surfaces are pressed together, here also if the two surfaces are pressed with more force, then the interlocking between the irregularities will be strong, so the friction will be more. Okay, so let us study one by one. Dependence of friction on the nature of the two surfaces. Please underline, friction depends on the smoothness or roughness of the two surfaces which are in contact with each other. Here also you can take the example. Now also see, this book I have kept over this table. So this table appears to be smooth, but it is not smooth, it is rough. Okay, the book surface of the book is also rough, but not so rough. Okay, so here when now I am moving the book with, see, I am moving the book with by applying small force, I am unable to move the book. That means there is the irregularities of this book and the table on which I have kept the book, that is locked, but the interlocking is not so strong. Okay, so if I will apply more force, what will happen? I will be able to move the book. Okay, so now initially when I applied less force, I am applying force, I was unable to move the book because of the interlocking. There is a force of friction, and this force of friction is opposing the motion of the book. But when I applied more force, so the applied force becomes more than the force of friction, and the book started moving. Understood or no? And the interlocking also, it was understood. So and here, since the surface is not so rough, the interlocking is not so strong. Now on the same book, okay, if I will apply, now see, the book is, I am applying, if I will apply some force, less force I am applying, okay, here I will be able to move the book. Okay, because now see, I am applying the force here, okay, but I am not applying very hard, I am applying less force, and on this side I am applying the applied force. So you see, I am able to move the book without making much effort. But when I will increase the force here, what is this? Actually I am increasing the weight on this book. So now I am applying the force, but I am unable to move the book. Why? Because on applying more weight, okay, or applying more force on the object, the interlocking becomes strong. Okay, so this is very simple experiments which you can also do. Okay, for this please open page 216. Now here, this is an activity. This activity you can do, it's very easy. Okay, now see, this is a brick, okay, which is placed over the floor. Now as I told you, the surfaces may appear to be smooth, but they are not smooth, they have irregularities. Maybe irregularities are not so much, but they have irregularities. Okay, now this is the brick here, and just tie a string around the brick like this and attach it with the spring balance. This is the spring balance in the center. This is the scale where which has the readings, and there is a pointer. So this pointer shows the reading, it shows the weight. Okay, now attach this string with the spring balance and pull this brick through the spring balance. You will see initially it will not move. Okay, this brick will not move. Now why it is not moving? Because there is a force of friction. So interlocking of this object of floor and the the irregularities of the floor and the brick, they are interlocked. So that is why there is a force of friction. Now the force is applied in this direction, but the force of friction is acting in the opposite direction due to the interlocking of the irregularities. That is why it is not moving. But if you will apply slightly more force, or if the applied force will become slightly more than the force of friction, then it will just move. Okay, and that point when it just moves, note the reading of the spring balance, and that reading will give you the magnitude of the force of friction. Because here before, when you pulled the brick, okay, when we pull the brick, what will happen? The brick does not move. That means force of friction is there, and this force of friction is more than the applied force. Okay, now if you will pull it slightly with more force, it will just start moving. So, and note the reading. So when it starts moving, what does it shows? The force of friction, the applied force is slightly more than the force of friction. So it also gives us the magnitude of the force of friction. So here, if it's showing, suppose if it's showing any reading 2 Newton, or it's showing 3, let us say it's showing 3 Newton. And 3 Newton, it is the force when it just starts moving, okay, or this pointer is showing the reading 3 Newton. So, and 3 Newton is that reading when it just starts moving, which shows that the applied force is 3 Newton, and this applied force is slightly more than the force of friction. So it also gives us the magnitude of the force of friction. So force of friction is 3 Newton. Understood or no? So now again, now here what you do, you just wrap it with the polythene and repeat the activity. You pull it, first you pull it, okay, it will not move. Okay, why? Because force of friction is more than the applied force. Now you pull it slightly, you pull it, the brick will start moving. Note the reading. That reading will give you the reading of the applied force as well as the magnitude of the frictional force, because it will move only when the applied force will become slightly more than the frictional force. So it will also give us the magnitude of the frictional force. You will find here, when the brick is wrapped with the polythene, okay, you will find the reading is less, which means the force of friction is less. Polythene makes the surface more smooth. So here the interlocking is not so strong. Now in the third case, just wrap it with a jute cloth. You will find that, again repeat the same activity, you will find that the applied force, the force which is applied to move it, or just to tend to move it, is much more than the first two cases. So here the force of friction is maximum, because here the irregularities of the jute cloth is more and the interlocking is more as well as strong. So force of friction is also more. So force of friction is more, so the applied force will be more or no? So that is what is given here. So please underline, the force of friction depends on the nature of the two surfaces. If there are more irregularities, there will be more interlocking, or the interlocking will be strong. So force of friction will be more and the applied force will be more. If the surface is smooth, interlocking will be not so strong and not so much, force of friction will be less. Okay, so same activity, any one activity you can read. So it's there in both the activities, it's shown that how it force of friction depends upon the two surfaces in contact with each other. Now dependence of friction on the force with which two surfaces are pressed together. Definitely if it is pressed hard, the interlocking will be more and the force of friction will be more. If it's pressed not so hard, with slight or with less force, what will happen? The interlocking will not be so strong and the force of friction will be less. Now you see, these are the two boxes. This is light box, this is heavy box. Now the force required to move this box is much less compared to the force required to move this heavy box. Now this light box, the weight of this light box is what? We can say it's the force which is acting down. So here the force which is acting down on the floor, you can see this box is in contact with the floor. So here the force which is acting down on the floor is much less. So the interlocking of the irregularities is also less. Okay, they are not interlocked deeply. Okay, now you cannot see here, it appears the surfaces appears to be smooth, but I told you then also there are irregularities. So if the weight is less, the force with which this box is pressed over the other, or the force you can say with which the interlocking at the surface, the bottom surface of the box is pressed with the interlocking of the floor, is very less. so the interlocking is not strong, and just by applying slight force the box can be moved. Whereas in the other case, here this is the heavy box, the weight of the box can be is a force which is pushing the box down. So if the weight is more, the force is more, so both the surfaces are pressed against each other harder. Here the force is more, so the interlocking will go deep inside the interlocking of the surface of the floor. The interlocking will be strong and the force of friction will be more. Okay, so all these things is explained here. You can just go through it. Okay, because floor is pressed harder, yes, that only it's given here. So here large amount of force is required to move the box. Here less amount of force is required to move the box, because here the force of friction is less as the interlocking of the irregularity is not so strong. Here the force of friction is more as the interlocking between the irregularities is more strong. Okay, so please underline, open page 218. Please underline, in journal, greater the weight of the object which moves over another object, the greater will be the friction between the two. And here this also underline, friction between two surfaces depend on the force with which the two surfaces are pressed together. Now there are three types of friction: static friction, sliding friction and rolling friction. Static friction is maximum and rolling friction is minimum. We will study these one by one. Okay. Now same thing is explained here also. Now first of all, what is static friction? It is the maximum frictional force. Please underline, is the maximum frictional force which is present between any two surfaces when one object just tends to move, means it just starts moving. So that is the frictional force, and it is the maximum frictional force. Definitely it is the maximum frictional force, because friction it opposes the motion. So friction it increases, but when it just tends to move, at that point the friction is maximum. So the maximum frictional force present between any two objects when one object just tends to move or slips over the surface of the other object is called as static friction. Very easy. Same thing also here, also same thing is explained, which I have already explained you. Here this is the wooden block, okay, and this is the tabletop. You can do also, you practice, see also this one is a very simple activity. Now here again this block is tied with the spring balance and it is pulled. Now initially you will see that the box will not move. Now why the box is not moving? Because there is a force of friction. Okay, so force of, now here with the pull, the force is applied in this direction. Okay, but the frictional force is in the opposite direction. So this frictional force is opposing the motion of the block in forward direction. So now this box is pulled with slightly more force in such a way that the box tends to move, or it just starts moving. So at that point when it just starts moving, note the reading here, it's shown 5 Newton. So what is this 5 Newton? This 5 Newton is the magnitude of the applied force. We can also say that this is the magnitude of the frictional force, because initially when we moved the box did not move. That means the force of friction was there. Again we applied more force, the box just started moving. That means the frictional, the applied force have become slightly more than the frictional force, or you can say the frictional force was maximum at that point. So the magnitude when it just starts moving is actually the magnitude of the frictional force. It is the maximum frictional force with which the movement of the box was opposed. Okay, and it is also the magnitude of the applied force, but here the applied force is slightly more than the frictional force. So the frictional force is maximum at that point. So here what is the frictional force? 5 Newton is the magnitude of the frictional force. Okay, that's what here you can see. Please underline, when the wooden block tends to move or slips on the tabletop, the spring balance shows the reading of 5 Newton force. This means the magnitude of the static friction between the wooden block and the tabletop is 5 Newton. Understood? From the above discussion, we conclude that the force required to overcome friction at the instant an object just tends to start moving from the rest is the measure of the static friction. Okay, so that force, when it just starts moving, here the reading is shown, so that is actually the maximum static friction. Okay, that is the frictional force and the maximum frictional force, because here the applied force has become just slightly more than the frictional force, or slightly, okay, when it just moves. So at that point the frictional force is maximum. Please note that in case of static friction, the object is actually not moving or sliding over the other object. It only tends to move. It just starts moving. It's not that it starts moving and it's moving. It just moves. Okay, and understood? So that is the static friction. What is sliding friction? The frictional force present when one object moves slowly. Here it moves. The object is moving over the surface of the another object is called as the sliding friction. Here it tends to move, okay, but it's not, it moves, but then it's not continuously moving. In the sliding friction, it moves and it is slowly moving over the surface of the other object. So here what happens, you will see here it moves, okay, and here when you see the reading, that reading gives us the maximum sliding friction. Okay, now let us see, now increase the force applied to pull the wooden block a little more. Now see, first what happened, this was the block, okay, when the force was applied, we applied the force like it's shown here, the force applied was 5 Newton, it simply moved, so that is the maximum static friction. Now so it moved, okay, now this is in motion, let us say this is in motion and more force is applied, so to keep it moving, okay, and this force is 4 Newton. So this applied force is 4 Newton. So we can say this 4 Newton is actually the sliding friction, okay, and always this sliding friction is always lesser than the static friction. Here it has been found that the force required to keep the wooden block sliding once it has started moving is less than the static friction, okay. So the sliding friction is, so it's, let us say it's moving and more forces, it will stop, so some force is applied to keep it moving, and that force is the sliding frictional force. Now why the sliding frictional force is lesser than the static friction? Because in the static friction what happens, the see here, please underline, sliding friction is smaller than the static friction. Why? It is easier to keep the object moving, okay, if any object is in motion, it is easier to keep it in moving. Why? Because why it is easier to move it, keep it moving? Because the interlocking is not strong. Now in the static friction, in the static position, when the wooden block was in a stationary position, the interlocking was strong. So in order to overcome that interlocking or overdo that interlocking, more force was applied. But if the object is already in motion, so the interlocking is not so strong. You can see here. Okay, let us see why sliding friction is smaller than the static friction. This is explained as follows. When the object has already started moving, the irregularities or on the surface do not get enough time to lock into the irregularities of the other surface. That's what I said. The interlocking is not so strong. It's already moving, so it does not get stronger. Okay, doesn't go deeper inside the irregularities of the other object. So that is why it is less. Rolling friction is the minimum. What is rolling friction? When an object like a wheel rolls over the surface of the other object, the resistance to the motion is called rolling friction. That's very easy. Like if a ball is rolling over the floor, so what is happening? The force, there is a force which opposes the movement of that ball over the floor. That is the rolling friction, and it is minimum. It is very, very less. Okay. Rolling reduces friction. Now here, if you have to move this book, you have to apply more force, but over these pencils it can be moved easily. So this is the rolling friction, this is the static friction. Static friction is maximum and rolling friction is minimum. So please see here, it's much easier to move an object kept on the rollers than to slide it because rolling friction is much less than the sliding friction. Here also you can see even the see here, okay, I'll read out. We conclude that when an object rolls over another object, the rolling friction comes into play between them. Rolling friction is much smaller than the sliding friction. Since rolling friction is much less, it is easy and convenient to pull a heavy luggage. Okay, please underline heavy luggage fitted with rollers. Okay, because the friction is less, so the luggage can be easily moved. Okay, the round logs of wood acts as rollers, a kind of wheels, and make it much easier to move the heavy machine kept on them. Here, so it is easier to move a heavy machine. A large block of stone being moved on the, see, these are the rollers and the stone can be moved over it. So this is about the 3 types of friction. In the next class we will discuss advantages and disadvantages of friction. So friction is a necessary evil, and the advantages, what are the advantages of friction and what are the disadvantages of friction, that we will discuss in the next class. And then we will discuss methods of increasing and reducing friction also. And metals and non-metals, mainly we will discuss the physical properties of metals and non-metals in detail, and we will do some of the important chemical reactions. Okay, and then I'll finish the syllabus. So if you have any doubt, you can clarify your doubts during live session or even during the clarification hour. Thank you, students. Have a nice day.